Okay, thanks for coming to my talk. How many people here attended the first keynote today about GraalVM? Okay, so a lot of people. So I'm probably going to skip a couple of parts in the beginning since you are comfortable. So if you have any questions, feel free to ask in the end or after. I'll try to not repeat a lot. So who am I? I'm Rodrigo. I work at Codacy, it's a software as a service providing static analysis, basically finds issues, security, and helps you track quality in your teams. We are hiring. If you are interested, let me know or check our page, basically. Okay, so today I'm going to go to three things. What's the problem I'm trying to solve? I'm going to do kind of a follow in a solution, and I'm going to show you all the challenges that I faced while trying to achieve this. So what do I think is limiting us today? Basically, when you think about Java in general, people don't usually use it for small things like scripts or CLIs and etc. because it has a lot of overhead, the initial start performance, usage of memory, CPU, the dependencies, the setup, you need to have a GRE, all of that makes it a bit hard. So people end up using Python, Ruby, or Bash to do it. That's a bit sad because sometimes people don't test the code and cannot achieve the same they would do in a normal microservice. And even after that, usually in some languages, the artifacts can compilation times, the artifacts can be big. It's not, I would not say it's hard to distribute, but if you are deploying, you might need to bring the dependencies in your code, and etc. And it's a bit disgrupped. So, how can we tackle this? It also obviously allows for nice things, but you have some downsides. So the biggest downside is performance. Like talked in the morning in the keynote, you will obviously not reach yet peak performance of JIT compilation, but with the profile-guided optimizations, you can instrument with the instrumentation that the GraalVM team provides your application in a production environment. It collects some data, and then you can pass to GraalVM to make it a bit better. So in the end, what is it going to do behind the curtain is basically it grabs our application, your dependencies, bundles it with Substrate VM, performs some initialization that I'll then explain a bit better. It discovers all the objects that are reachable from the main entry point that you choose. It can perform some heap snapshots of some parts that were initialized, and then the ahead-of-time compilation will generate a native executable for the system. About how I think this is useful. So one of the projects that I started using this in my current company is basically, we run a lot of tools for static analysis. They are usually small CLIs, like you can check some for JavaScript, ESLint, or check style for Java, or even Scala style for Scala. And they usually are done in a lot of languages, but since we work with Scala, we would like to do a wrapper in Scala since we are more familiar with it. And usually what we end up, it's a wrapping file or two with 100 lines of code, and in the end, we end up with a Docker with 200 megabytes, which is huge. And seems kind of a problem if you have to run this a lot of times and to develop it. And also, since these are very short-lived applications, the overhead of starting a JVM and doing all of that, it's not very good if it's something that you are running multiple times and it has a very short lifespan. So, how can we make this a bit better? It's fairly easy. What you need to do, and this is an example with SPT, but it's very similar to what was talked in the previous talk on how it gets their application. You need to compile it, so produce classes, jars, one of those you can choose. Then, for example, if you're using SPT, you can do SPT compile, then you can export the runtime class path available in your system, and after that you can invoke native image, passing the whole class path you got from SPT, a name for your binary, and the main class for it to start your application. And basically, that's just it. There is no anything else that you need to do for normal use cases. Obviously, you might not want to do this, so there are a couple of tools for SBT, Maven, and grail that you can use that will do this process for you and will integrate natively with your build tool, which is nice. You can also check the links later, and probably there are many others that you can check. So in the end, how did I improve what I was doing before? So like I told you, I had a CLI, and in this case, this was inside the Docker. So the part, in this example, I'm wrapping a ESLint, so which is from JavaScript. And the 150 megabytes that it brings, I couldn't trim yet, so I have to live with it. But then in the JVM part, we were bundling 90 megabytes. Even after we trimmed down the GRE parts that we are not using, removing crazy stuff there by hand, we couldn't get it below 90 megabytes. together with our application. And after compiling to GraalVM, we got a binary with 25 megabytes with everything included. And the rest was basically 5 megabytes for the Alpine base, which we just need because of Node. So if I was just running the wrapper, I could even use a Docker Scratch image. I don't need anything in the system to run it, which is pretty nice. If I was, for example, I was just wrapping Scala style, I could invoke Scala style programmatically, and I would just have a simple binary to run. In the end, I got an improvement of 65 megabytes, which is a lot if this is downloaded millions or even if just thousands of times per day. Obviously, this is all very interesting and very simple, but there are a couple of challenges. We are working in a closed world assumption, so there are a couple of things that you have to keep in mind. First of all, this is a very ongoing developed project, so it has a lot of things changing, a lot of things improving, a lot of features that are still not done being implemented, so you need to keep track of what's happening. And a couple of tips for you to start. So you should set a no fallback option. It's important because if there is certain types of errors when generating the binary, GraalVM native image will fall back to the JRE in the system. So sometimes you might get an image and you think, oh, it's native, but no, it's just using the Java in your system. So for production, I would advise you to use always the no fallback because you just want the native binary. And if it fails, you need to understand why it fails. And then there are two more flags that might be important for you to debug. So the first one is basically for you to get reports of unsupported elements in runtime. It might be interesting for you to delay some errors to later so you can understand better what's happening. And also to allow an incomplete cast path to the same thing. You are delaying problems so you can understand better where exactly it is failing while trying to check your application and, like I said before, trying to understand all the parts that are reachable. Other important things. If you have dynamically load of things, classes, or etc., you might have some issues. For example, one of the issues I had was using Scala XML. I reached the point where some class was not being bundled, so a native image was searching the class path. It was not finding a class since it was obviously a string loaded, I think with some sort of reflection. I'm not completely sure about that part. So in this case, what I had to do, as soon as it told me the class is failing, I had to specifically say, when you are bundling, please take this class. It's going to be needed in runtime because it's going to be very pedantic and remove everything that you don't need. So it's very important for you to test these type of applications. Other things I think already referred in the morning, I'm not pretty sure. If you have reflection, JNI, resource usage, or proxy configuration, you might have to configure this by hand, like a JSON file describing it. But again, you have a tracing agent that you can run your application with the normal JIT VM. And by running through all your code, you will be able to generate these files without that much effort and achieving the same result. So now the most important part, at least for me and for the use case of having smaller applications. So there's a lot of stuff that you bring that you don't use. So you might have imported a library which has 200 classes, but you are only using one, and it's usually a pain. Or you might just be not using the Java HTTP part, so why are you bringing it? And what GraalVM will do is, by default, it will remove all the trash. And that's very good. But then there is a slightly strange thing that you have to deal with. So about class initialization. So by default, in the beginning, GraalVM was basically setting up everything to be initialized at build time, if I'm not mistaken. And this is very interesting because static initializers, and there are other things that you can do at build time. So if you are loading a JSON, you can do this at build time. The heap will be snapshotted, and when your application starts, it will be fairly faster, and everything is ready to run, instead of having that slower startup time. Obviously, this is not really easy to do automatically. So after they released the stable version 19, they had to revert the change. And I think by default now everything is done at runtime. But I would advise you to try to decide what things you can run at build time. So for example, if you are just loading files, doing things that don't matter when they will be done, you should tell native image, so okay, please load this package or this class at build time. It will make your application faster. But if there are things that you don't want to initialize at build time, so for example, imagine you are doing a datetime now, that will be an issue because you will get the date of the build and not the date of the runtime, which will then cause a lot of problems in your code. So you might have to do kind of by hand deal with this. I still think it might be able in the future to get something like you to select the classes, which I don't think it's possible, that you don't want to be initialized, but now you need to say the place where the class is being used. At least that's the thing I could do. I'm not completely sure about that part. But basically, what I advise you to do is to check your application, understand what parts you can initialize, and as many parts as you can. If you do it at real time, it will help a lot in the startup of your application. The last part that I want to talk about is about the crypto part. So the JVM brings a lot of crypto stuff by default, and it's bundled. You never see it. You just use HTTPS calls, you cipher stuff, and it works fine. But now here, there are a couple of details. So first of all, you have to enable it. So if you need to use protocols, special protocols like HTTP or HTTPS, you have to manually enable them. And with HTTPS, you have an issue, which is if you are using elliptic curve algorithms, which are provided in normal JVM by libsunec, so the libsun for elliptic curve things, you will have to bundle this with your native image, with your native binary, which is kind of a bummer because you just got a binary which is standalone. I can run it everywhere. I can send it to someone. Now I have to bundle it with other thing. So if you need elliptic curve, this is an issue. I don't think anyone solved it correctly yet. There are a couple of issues open in GitHub where people are trying to improve this. There are people trying to replace the elliptic curve part, for example, for another implementation like Bouncy Castle. I'm not sure if anyone tried to use from Coreto, for example. I think they have a crypto library too. In my case, since I was not using the elliptic curve algorithms, what I did was just I disabled these algorithms in the JVM where native image was compiling, and I got an application which was doing HTTPS fine because I was not using that protocol. So for now, this is a workaround that you can use if you need to do requests, like if you're doing a CLI that needs to do a post and etc. It's definitely something you might want to check. So that's all I had to say. So other things I found very interesting is that I'm pushing a lot at my company to have people try these out. So because we can do Scala code, it's tested. It's much better than having a bash file that starts growing a lot. So if it's small, it's okay. But when you start doing logic, I think it's a bit crazy. So if I can write a native image that I can then just send somewhere, I think it's amazing. So I think we can explore other things like trying to build the polyglot part. It was referred in the morning, so integrating maybe Scala code, invoking some Ruby library that I don't have as good support in Scala as I have in Ruby, and bundle this in a binary. Or even native microservices. Also talked in the morning, you can start running like Micronaut and etc. And you have an amazing startup time for slow things. Maybe in the long run, it might still be a bit tricky, but it's something you might consider for some use cases. I have a lot of links here that might be interesting. So things about startup time, class initialization, how you can tweak performance, how you can do the tracing agent, and a lot of resources like how you can chat with the team. They are very responsive. They help a lot if you have any issues, and some other resources that I found important. And that's it. Thanks. Thank you.
Thank you very much. So we do have one question for you. The question is, can we run the binary produced by native image on Alpine Linux because it uses musl instead of glibc? It's in the Q&A. Yeah.
So that's an interesting question, but in the end, if you generate a static linked binary, everything is bundled inside, and from my tests, I was able to get a normal CLI and even a CLI doing HTTP calls running on a Scratch image, so no system installed, basically. I think you can also run a dynamically linked one, which will be smaller because I think it uses the libraries from the system. But if you choose the static, I don't think you should have issues. But maybe there is something that I'm not seeing.